Okay, so today we're going to take a look at a couple examples that are going to help us practice for our Unit 3 test. Now, I just want to point out, these are not in your packet, so you can just copy the examples right down onto a piece of paper and try them out on your own first. All right, this first one is a rational equation, so it says solve for x. Okay, I'd first like you to try this out on your own and see if you could do it on your own, and then you can hit play and see how you did. Now, we know in order to solve for x, the first thing we have to do is we have to find a common denominator. So you want to look at the denominators, and if any of them can be factored, that's the first thing you're going to want to do. So I could see right here, this last denominator can be factored, right? We could pull out a greatest common factor of x, which leaves us with x minus 7. All right, so I'm going to cross off what we originally had so we can look at that. Now, if we look at our other two denominators, this one has an x minus 7, this one has an x, and this one has both. It has the x and the x minus 7. So our common denominator is going to be x times x minus 7. All right, so if we look at this first fraction, right, we want to say, well, what is this missing that our common denominator has? Well, it has the x minus 7, right, but it's missing the x. So I'm going to put it there, okay? I'm going to put an x. Let me change colors so we can see what we're doing. I'm going to put an x in the denominator. I'll put parentheses around that to show we're multiplying by x. And if I put it in the denominator, I have to put it in the numerator as well. All right, now let's look at our second fraction. And we want to say, well, what is this denominator missing that the common denominators have? Well, it has the x, right? But it's missing the x minus 7. So I'm going to multiply top and bottom of this fraction by x minus 7. Just slide it in there. Sometimes I like to rewrite the problem so I have a little more room rather than trying to squish that. But we could see now all of our denominators say x times x minus 7. So since they're all the same, we can cross them off. Okay, I'm going to cross them off. All right, and what we're doing is we're solving this equation that we're left with in the numerator. All right, so I always like to rewrite it because the reason I feel like it's important to rewrite it is so that we see that this negative here is attached to the 1. So we have a negative 1 we're distributing. Okay, so let's rewrite the equation, and this is what we're going to solve. All right, so when we distribute, we get x times x is x squared. X times negative 3 is negative 3x. Negative 1 times x is negative x. And negative 1 times negative 7 is positive 7. And I'm going to bring down the equals 28. All right, so now we know we want to get one side of the equation set equal to 0. So I'm going to subtract 28 from both sides, and then the right-hand side of the equation does equal 0. All right, so over here, let's just combine our like terms. Now, x squared doesn't combine with anything, so I'm going to bring it down. Negative 3x and negative 1x combine to give me negative 4x. And then positive 7 minus 28 combine to give me negative 21. All right, so this isn't so bad. We're just going to factor. So since there's a 1 in front of our x squared, we can jump right into setting up two sets of parentheses. And don't forget to bring down the equals 0, right? You have to keep it in equation the entire time. And then since this is an x squared, we're going to put an x in the first spot in each parenthesis. And we're just going to come up with two numbers that add to negative 4 and multiply to negative 21. So I guess that would be what? Negative 7 and positive 3. And when we make our t-chart, we get x equals 7 and x equals negative 3. Now remember, you don't just right away circle these answers. You want to look at them and check and say, all right, here I have a 7, right? When I substitute it back in to my original denominators, does it create a 0 in any of the denominators? And if you want, you know, you can just kind of, I'm going to erase that for a minute. So we're just focusing in on the denominators. So here, if I take this 7 and plug it in, 7 minus 7. Well, 7 minus 7 is 0. And we can't have 0 in the denominator of a fraction, right? That makes it undefined. So I actually have to take this answer and cross it off. All right, that right there is called an extraneous root. All right, now let's take a look at the negative 3. And keep in mind, it only has to create a 0 in one of the denominators. I mean, it can, you know, if it creates a 0 in one or more of the denominators, you cross it off. All right, so when we look at the negative 3, negative 3 minus 7 is not 0. Okay, so that's okay. Here, if we plug that in, we don't get 0, right? We get negative 3 in this denominator. And here, if you plug in a negative 3, negative 3 squared minus 7 times negative 3 also is not 0. So this value doesn't create undefined fractions, so this one we're going to keep. Okay, the second example. So what I'd like you to do, again, is to read it, try it on your own, hit play, and see how you did. Okay, so part A asks us to use the remainder theorem to determine whether x plus 5 is a factor of f of x. So they don't actually want you to do long division, right? Long division, we know that, if we wound up with no remainder, then this would be a factor. But they want us to use the remainder theorem. Now, the remainder theorem says, instead of dividing by x plus 5, we can take x equals negative 5. We can plug in negative 5 wherever we see an x. Okay, so I just found f of negative 5. Wherever I saw an x, I replaced it with a negative 5. Now, you can plug this entire thing into your calculator, or if you prefer, remember, we learned how to use the store button. Okay, so in my calculator, I plugged in negative 5 store x. Remember, the store button is the one that says stow on top of the on button. And then I just plugged in what f of x was equal to. And when I hit enter, I could see it equals 0. So here we found that f of negative 5 is equal to 0. So is x plus 5 a factor? Yes, it is. X plus 5 is a factor because f of negative 5 equals 0. Okay, so you want to write that out. And what that means is if we were to have divided f of x by x plus 5, we would have wound up with a remainder of 0, with no remainder. Okay, now what they want us to do is they want us to determine the zeros of f of x. Now, in order to determine the zeros, we first have to figure out the factors. I mean, we know that x plus 5 is one factor, but we have to find all the factors. Okay, so remember, we can do that through long division. If we know that x plus 5 is a factor of f of x, then it will divide evenly into it. And when we divide it, whatever the quotient is, our answer, will be the remaining factors. Okay, so let's do it. All right, so I'm taking f of x and dividing it by x plus 5. All right, so I want to look and say, what do I need to multiply x by to give me 3x cubed? Well, I need to multiply it by 3x squared, so I'm going to put that on the top here. And then let's distribute. 3x squared times x is 3x cubed. And 3x squared times 5 is positive 15x squared. All right, and we know we have to subtract, so we're going to change our signs and circle. Change our signs and circle. All right, so the first two terms cancel off. And then when I combine negative x squared and negative 15x squared, it gives me a negative 16x squared. And I'm going to bring down the next term. All right, so we're going to start the process again. I look at my first term on the outside of the division bar and my first term underneath the division bar. And I say, well, what do I multiply x by to give me negative 16x squared? Well, negative 16x, so I'm going to put a negative 16x up here, and then let's distribute. Negative 16x times x is negative 16x squared, and negative 16x times 5 is negative 80x. All right, so now we're going to change our signs and circle, and the first two terms cancel off, like always, right? That should happen. And then when I combine negative 92x plus 80x, it gives me negative 12x. And now finally, I'm bringing down this last term, so I know this is my last time I'm going to have to do this. So I look and say, what do I multiply the first term on the outside by to give me the first term under, here, under this division bar? So, I need to multiply x by negative 12 in order to give me negative 12x. So I'm going to put that negative 12 right on top. Now, remember, x plus 5 is a factor, so we should not be winding up with a remainder. If we wind up with a remainder, it means we made a mistake somewhere. So let's see what happens. All right, negative 12 times x is negative 12x. And then negative 12 times 5 is negative 60. And look at this. This is going to work out, okay? So when we change our signs, everything cancels. So it means we don't have a remainder, which is great. All right, so now we know that it says to determine the zeros. So we know that first thing we have to find is the factors. X plus 5 is one factor, right? And our quotient that we were left up with up here is the other factor. So I'm going to write this as x plus 5 times 3x squared minus 16x minus 12. Now, it does say to determine the zeros. So what that means is we have to set this equal to 0. All right, now, this right here, this can factor further, so we're going to have to do that, all right? So let me just bring down this x plus 5. And in order to factor this further, right, since we have a number other than 1 in front of our x squared, we are going to have to do the rainbow. So 3 times negative 12 is negative 36. All right, so first of all, when you do the rainbow, remember, we don't set up 2 sets of parentheses, right? I'm going to set up 1 big parenthesis because we bring down our first term. Pen wasn't writing. Bring down the last term. And I'm going to split this middle term up into 2 terms, okay? And how I'm going to find those terms is I'm going to find 2 numbers that multiply to negative 36 and that add to negative 16. So I guess that would be what? Negative 18 and positive 2. Okay, so we're going to have a negative 18, and don't forget to put the x next to it, right? Because if this is an x, we need the x here, and a positive 2x. Sorry, I'm really trying to squish this. All right, so let me bring my x plus 5 down, and now we're going to do grouping. So out of the first 2 terms, I could pull out a 3x, which leaves me with x minus 6. And out of the last 2 terms, I could pull out a positive 2, which also leaves me with x minus 6. And don't forget the equals 0, right? We need that on every single step. We have to keep it as an equation. All right, so I'm going to bring down my x plus 5, and then I'm going to take the 3x and the plus 2, right? I'm going to take the terms that are in front of our common binomial, and I'm going to group them together as one of our factors. And then finally, I'm going to take that common binomial of x minus 6, and that will be my third and remaining factor. Now, I just want to point out, if the question had said to determine all the factors, right, I wouldn't have this equals 0 here. This would be my answer. This would be the factors, and I would stop. But because it says to determine the zeros, I'm going to make a t-chart and keep going, all right? So under here, I get x equals negative 5. That's a 5, sorry about that. Here, I mean, some of you can look at it and say, all right, I'm going to get negative 2 over 3. If not, just take that factor and set it equal to 0 and solve. Okay, so in order to solve that, I would subtract 2 from both sides of the equation, which leaves me with 3x equals negative 2. And then I would divide by 3, so that leaves me with x equals negative 2/3. All right, and then over here, this one is, pretty straightforward to just look at. You get x equals positive 6. So those are my 3 zeros. All right, if you want to check, it's super easy to check. You can just take each of these x values and substitute it into f of x, kind of like we did up here in part A. And when you substitute them in, they should all be equal to 0. All right, so the last question we're going to take a look at today is actually the very last question in your Unit 3 packet. Okay, so if you turn to the very last page, number 31, this is the question that you will see. All right, so what I'd like you to do is read it and realize there's actually 2 parts to this question. See what you can do, and then again, hit play, and hopefully you got it right. If not, just follow along and find your mistakes. Okay, so this question talked about how Sarah was fighting a sinus infection. This function represents the nasal spray used to fight the infection, and this function right here represents the antibiotic. Okay, so there's 2 parts to the question. Let's see. The first part says, determine which drug is made with a greater initial amount of active ingredient, and they want us to justify our answer. Okay, I know they don't call this part A, but you know what? I'm going to call this part A, just so I can kind of organize my work here. All right, well, let's think about it. So if we want to figure out which is made with a greater initial amount of active ingredient, well, think about it. If we want to figure out initially how much she's taking, doesn't that mean that no time has passed? Basically, she's just initially taking the drug, and time has not passed. So if no time has passed, we're going to replace these t's with zeros. Okay, so I just plugged in 0 for t, right? no time has passed when she initially takes the drug. All right, so just plugged in 0 for all the t's into n of t. And you're just going to determine what this is equal to. I mean, you can use your calculator or you can do it by hand, but either way, you're going to wind up with, let's see, I get 1.4. And the units here would be milligrams. Okay, and then when we plug in 0 into the antibiotic, it would be 9 over 0 plus 3. So 9 over 3, which simplifies to 3 milligrams. So if we want to figure out which one had the greater initial amount, we could say this, right? This is bigger. The antibiotic, A of T, has the greater initial amount of active ingredient. Okay, now, let me just move this up and give myself a little room. The next part, let me highlight that so it kind of stands out. Sarah's doctor told her to take both drugs at the same time. Determine algebraically the number of hours after taking the medications when both will have the same amount of active ingredient remaining in her bloodstream. All right, so to me, I mean, the word that pops out here is the same. Okay, that's our key word. If we want to figure out when the medications are the same, let me just scroll back up so we could see both medications. We want to know, when does the nasal spray, the amount of drug remaining in her body from the nasal spray, equal, right? The same means equal, the amount of drug remaining in her body from the antibiotic. So if we want to know when this is going to be the same as this, we just set them equal to each other. Okay, I'm going to also, let's see, I'm going to label this. I'm going to switch colors here now, but I'm going to label this part B, and that way I have my work for part B down here. All right, so here we go. So I took N of T and set it equal to A of T. All right, so all we're doing is just solving a rational equation. Now, we know when solving a rational equation, if any of the denominators can be factored, you want to do that first. So we could look right here, and you could see right off the bat, this one can be factored, okay? We just have to come up with two numbers that multiply to 15 and that add to 8. So positive 5 and positive 3. Okay, so this is factored to t plus 5 and t plus 3. All right, so we're going to use that denominator now. So let's just cross this off so we're not looking at it anymore. All right, so now we want to find a common denominator. Now let's start with our first fraction. You want to look at this denominator and say, what is this denominator missing that we have in any of the other denominators? Well, look, it's missing the t plus 3. All right, so we're allowed to put it there. So I'm going to put it right here, t plus 3. Now, if I put it in the denominator to keep my fraction equivalent, I also have to put it up here in the numerator. All right, well, let's look at our second fraction. What is this missing that our other denominators have? Well, absolutely nothing. Look, it has the t plus 5, which we have here, and it also has the t plus 3, which we have in the other. So this one's not missing anything. So we're going to leave that numerator and denominator alone. Then you want to look at this denominator and say, well, what is this missing that the other denominators have? It's missing the t plus 5. So I'm going to put it there. And if I put it in the denominator, I also have to put it in the numerator. Okay, so now that all of our denominators have a t plus 5 and a t plus 3, remember, we're allowed to take them and just cross them right off. Okay, so what we're solving now is this numerator, what we're left up here. Now, see this t plus 1? Make sure when you rewrite it that you put it in parentheses, because we're doing this t plus 1 times this t plus 3. So to show that you're multiplying the entire first binomial by the entire second binomial, they both have to be in parentheses. Okay, and then let's bring down the plus 18 and bring down the equals 9 times t plus 5. All right, so we just have to solve, so this shouldn't be too bad. All right, so right here we're going to double distribute, right? T times t is t squared. T times 3 would be 3t. 1 times t is 1t, which is just positive t. And 1 times 3 is 3. I'll bring down my plus 18 and my equals. And then when we distribute the 9 times t is 9t. And 9 times 5 is 45. You know, one thing I just also want to say, when I'm writing, you know, if I'm writing anything, I never make my t's like this. Okay, my t's never look like this. The only reason I do it in math, the only reason I put that little like tail at the end is so that it doesn't blend in with the plus sign. Okay, I mean, you don't have to do that, but for me, it just really clears it up. Is this the plus sign or is this a T? All right, so now let's see. I have two things I need to do in the next step. I'm going to do them both at once. I know I'm going to have to combine my like terms. And also, because I have a square in my equation, I need to get one side of the equation set equal to 0. So I'm going to do that all at once, okay? I'm going to first get the right-hand side of the equation set equal to 0 by subtracting the 9t and subtracting the 45, okay? Now, I'm going to line up the 9t, the minus 9t under these two terms, because those are like terms. Those are going to combine together. And I'm going to line up the negative 45 underneath these two terms, because they're just numbers. They're like terms as well. They're going to combine together. All right, so on the right-hand side of the equation, I have 0, which is what I wanted. On the left-hand side of the equation, this t squared, I don't see any other t squared terms, so it doesn't combine with anything. It just comes right down. And then 3t plus t and negative 9t all combine, okay? These three terms combine. So since 3 plus 1 is 4, and 4 minus 9 is negative 5, they combine to give us negative 5t. And then these numbers right here also all combine. Okay, so 3 plus 18 is 21, and 21 minus 45 would be negative 24. All right, and then we're almost done. We just factor, make a t-chart. All right, so here, because this is always the easier type of factoring when there's a 1 in front of the t squared, because you don't have to go through the whole process of rainbow. We just set up 2 sets of parentheses, and we put a t in the first spot in each parenthesis. And you're just coming up with two numbers that add to negative 5 and multiply to negative 24. So negative 8 and positive 3. And please don't forget to bring down your equal 0, okay? You have to have an equal sign in every single step of the equation. That's what makes it an equation. All right, so now when we make a t-chart over here, again, we need an equal sign, right? Because we want to keep it in equation. So t equals positive 8 and t equals negative 3. All right, so now we have to go back and think about what the question's asking us, okay? I'm going to just kind of scroll up for a minute. Can I do that? Oh, here we go, okay. So let's see. Determine algebraically the number of hours after taking the medications when both of the medications will have the same amount of active ingredient remaining in our bloodstream. So we're determining the number of hours. We're talking about time here. Now let's look at our answers. We wound up with t equals 8 hours, right? That's our units, hours, or t equals negative 3 hours. Well, this one we can cross off right away because you can't have negative time, right? So it looks like here, this 8 hours is going to be our answer. Now, one other thing that I do want to point out, the other reason why we cross off this negative 3 is because, think about it. Let's go back to our original fractions. Actually, I'm just going to look at this one right here. Okay, see that denominator t plus 3? If I take negative 3 and substitute it in for t, isn't negative 3 plus 3 0? And can we have 0 in the denominator of a fraction? No, we can't, right? Because that would make it undefined. So that's another reason why we have to cross this off. So this part B, or I called it part B, is equal to 8 hours. Okay, just a reminder, please make sure that you go into Google Classroom and check your answers to the review sheet with my answer key. And then anything that you got wrong, just watch the video, okay? If you got, whatever, number 2, 8, and 14 wrong, then I don't even know if there was a 14, but only scroll ahead and watch the ones that you got wrong. If you got them right, good. Okay, if you got them wrong, please watch the video and then make sure you practice that review sheet as many times as you need. The more you practice, the easier the test will be. Okay?